Okay, three-sum problem. Given an integer array nums, return all the triplets such that their value sum up to 0. So we need to identify three values that sums to 0, and there shouldn't be any duplicates in these triplets. So even though their combinations are different, they they shouldn't be added once again because they are considered duplicate. So now let me see. One approach is the brute force method by taking three pointers here. Suppose I left and right pointer. Let me take this example here. If we use the pointer here, ith pointer, fix it to the first position, and then left pointer to the ith plus 1 position, and finally the right pointer at the end index. Now for every ith outer loop, for every I with the pointer I outer loop, we will have to find all computations here. That will take three embedded loops, one within the other, so that becomes order of n cubed complexity. So that is very costly. So instead of that, what we'll do is I'll sort the array first. Sort the array and fix the point I first index, and pointer left to I plus 1th index, and right pointer to the last index, nums minus 1. So the length of nums minus 1. Now if we do this, the arrays will be in sorted order. For example, if this is sorted order, let me write that minus 4 minus 1 minus 1 0 comma 2. So now here we have pointer I pointing to the first index, and then left pointer pointing to the I plus 1th index, and then right pointer pointing to the right index, end index. So now by doing this, we can apply this part of the problem, array portion. We can apply two-sum sorted array algorithm, which means for every ith iteration outer loop with the ith pointer, we can squeeze L and R pointer inwards by checking whether nums of I plus nums of left pointer plus nums of right pointer equals to 0. Suppose if they are equals to 0, then we will add to result list. If sum is greater than 0, then it is bit farther away from the 0th value. We will reduce the right pointer such that it comes closer to the 0th value. If it is this case, then we will do a right minus equal to 1 by 1 position. If sum is less than 0, then we will know that the value is lesser than 0. Again, it moves far behind from the expected 0 value. So we will increment the left pointer. And finally, during the iteration, we always have to skip the duplicates. For outer loop, to check the duplicate value, we have to make sure the ith value terms of the ith pointer should be greater than 0, and when it is here, we can compare the previous value and determine if it is equal or not, because duplicate values adds up the same triplets to the array. which is prohibited here. We should not do that. So now for that reason we have to compare nums of I equals to nums of I minus 1. If this is the case, then we will skip this computation, continue. Similarly, for inner loop, we have to check for both pointers if they are if in their path if there are duplicate values. So to do that, we'll take a while loop for both and make sure left pointer is always lesser than the right, and then for left pointer, this is the condition, nums of left equals to nums of the next value. If it is equal to the current value, then we will increment the left pointer. Same way while right, and nums of right, if it is for right pointer, if the current value is equal to the previous value, then we will decrement the right pointer. Okay, so the algorithm is in place. Let's code the solution. First, let me sort the nums array, nums.sort, using the sort function, built-in Python sort function, and then I'll take a result list. Now the outer for loop for I in range len of nums minus 2. The I pointer runs till the last but third position, because we will have room for both left and right pointer at the end, so that they don't overlap or go out of bounds. So in this case, firstly I have to check for duplicates. If I pointer encountered any duplicates, for that we have to make sure if ith value is greater than 0, and now I have to see, I have to check the nums of I, the current nums value is equal to the previous value. This is the case, continue, skip the computation and move on. Now here we have to initialize the left pointer as I plus 1 and right pointer as the end value, the last value, len of nums minus 1. Okay, now coming to inner loop, we have to always make sure left pointer is always lesser than right pointer. Here let's take the total sum as the triplet sum value, which means we'll add all the nums of all the triplets value, nums of the left plus nums of right. Okay, so now we have to check if total sum is greater than 0. This is the case, the value becomes greater than 0, we will reduce the right pointer to come closer to the 0th value. Else if total sum is less than 0, we will increment the left pointer to make sure it gets closer to the 0th value. And then if it is finally equals to 0, then that's the last condition. We will append it to the results list. So add it to the result list, and dot append the triplets nums of I, nums of left, and nums of right. Okay. Once that is added, now we have to check for duplicates for left and right pointers. For this, we'll do again the while loop, and this condition check, and then the duplication check for left pointer equals to nums of left plus 1, this is the case, then increment the left pointer. Similarly for right pointer, the duplication check would be right equals terms of right minus 1. This is the case, we'll reduce the right pointer value. And finally, whenever this condition whenever the loop doesn't encounter, in both cases we obviously have to increment the left pointer to move the pointers so that it squeezes inwards. So in this line we will have the results list ready. The triplets are in the results list at the end, and finally we will return the result array. So the time complexity for this is the outer loop runs for n times in the worst case, and the inner loop also, both pointers, it traverses to the through the entire array for every iteration of outer loop. So that would be order of n square. And since the algorithm is computation is in place, so the space complexity is order of 1, unless we are storing for result list. So the result list space complexity would be order of n squared, because we are storing all combinations of triplets in the worst case. So let me run this. Let me see this works. Okay, solution is accepted, and I'll submit it. Okay, the solution works and it's successful. Thanks for watching.